this is Chris Wall with the Wall Network. Today's video is going to be on a technical deep dive of multiple subnet storage traffic, and this is going to complement the NFS on vSphere Part 3 posting. It's a 4-part deep dive series. Now what we're going to go over here is an actual configuration in the lab where we've got a kind of a typical NFS setup where this DV switch here, you see multiple NFS port groups, but we're only using one port group with one VM kernel on one subnet, and it's active to both uplinks. So you may think, oh well, that's great, it's using both uplinks, all good to go. In actuality, if we pull up ESXtop here, we'll see that VM kernel, which is VM kernel 3, is only using NIC 1. NIC 2 is actually not used. So if there were a failure event, yeah, it would go over to NIC 2, but really NIC 2 is not seeing any NFS storage traffic. Additionally, we've got a problem here because if we go into the storage piece, we can see that there are multiple NAS boxes linked, NAS 1 and NAS 2. If I ping those, let me clear this real quick. So if I ping NAS 1, we can see that he's on a 254 subnet and VLAN. My third octet is always the VLAN number. Ping NAS 2, we'll see he's on a 250 subnet and VLAN. The problem with that is, in this networking piece here, the only kernel that we have is a 254. So there's no 250 subnet. I've got the port group here for it, but there's no actual subnet in use. So what we're doing now is called routed NFS, which means in order to get that traffic to the host, it's having to go through a router at some point to hop over from one VLAN to another. Now if you ever are curious if that's happening or not, we can very easily figure that out. So let's do a trace route on the host to NAS 2, and you see right away it's got 2 hops. So if it's ever having to traverse a router, which 201 is it's doing intra-VLAN routing, we can see very clearly that it's having to escape out the default gateway to get there. We can also look at the routing table like that, and we can see there's actually no network, the 250 network known to this host, so it's going to have to use the default gateway to get there. So that's kind of a no-no. I'm not going to go into the whole is it supported or not thing. Well, let's just say I'm not a huge fan of the idea of routing packets for NFS, or really any traffic. So you may have a corner case, but let's try to avoid it if possible. So let's go ahead and add a new virtual port on here. And I'm just going to add a new adapter. I've already picked out an IP, and that's going to be on the B group. I'm sorry, the A group, 250. That's why I have it there, so I can easily remember which one it is. And let's put the IP in here, 10.0.250.52, and just a standard class C, and finish that up. And we see we've got it added here. Let's take a look at the top and see where it went. So that's VM kernel 6. You notice right off the bat here, because of the config that we have, it's put kernel 6 and kernel 3 on the same physical VM NIC 1. So we have a suboptimal configuration still. However, if we do a trace route, we'll see we're hopping one time. So we're no longer doing routed NFS. We fixed that problem, but we're still potentially could saturate one NIC and the other one's not being used. So we need to fix that. That's relatively straightforward. We're just going to need to go to the switch, and this is a very common tactic used with management in vMotion, where we're going to set the teaming so that one's active and the other one's standby. So for this first port group A, I'm going to make storage 1 the active, storage 2 the standby, and the opposite for B. So now we've flopped them. If I go to top again, we should very easily be able to see that. So 6 is on port group A, it's on NIC 1, and VM kernel 3 is on port group B on NIC 2. So now we've separated them out so they're not using the same uplink unless we have a failure scenario, which we want that to be able to happen. So because of these small configuration changes, we've now got it so that 2 uplinks are being used and nothing is being routed. We can also trace route 1 and see that it's just 1 hop, and 2 is 1 hop. So everything's on the correct subnet. In fact, if we pull up the route, we can see we now have a route to network 250 as well as the network to 254, and it knows exactly which interface to use. So it's going to send it out the correct interface, which is those VM kernel ports. You can also verify which VM kernel is going to what uplink just by clicking on it, and it tends to jump around a little bit. It's just a bug in the client here, but we can see the 250 port A is going to uplink 1, and the 254 port B is going to uplink 2. Expand those out so we can see that they're kind of pinned to each one. So in summary, to do multi-subnet NFS, we want 2 port groups. Each port group should have a unique VLAN ID and a VM kernel on a unique subnet. And that way we're making sure that there's no routed NFS going on. And in addition to that, we want to make sure the port groups are active on unique physical uplinks and standby on the others so that they don't try to compete with each other for traffic. Thank you for watching. Hopefully it's been educational. If you'd like to see more of the same, please feel free to subscribe to my YouTube channel and visit my blog at wallnetwork.com. Thank you.